Hello and a very warm welcome to everyone who are joining us today for this webinar from Problem to Powder Streamlining Metal Atomization for Industry. Uh, Brought to you by shreerapidtechnologies in collaboration to ATO by 3D Lab. I am Sonal Koth, Assistant Marketing Manager at shreerapidtechnologies, and I'll be your moderator for this session. It is an honor to see such a wide audience from R&D labs and engineering institutions, also powder metallurgy specialists, all eager to explore innovative approach in metal powder production. So let's begin. And here is the agenda we have lined up for you today. So it's introduction to Sri Rapid Technologies technical session followed by interactive poll Q&A session. So if you have any queries, please enter those into the Q&A section and it will be answered during this Q&A session. So let us get started from here. So to get us started, let's hear from someone who is from SRT, Lakshman, who will give us the introduction to Sri Rapid Technologies. With over 12 years of experience in engineering, Lakshman is an expert in additive manufacturing, skilled in technical sales and customer solution. So let's move on to Lakshman.
Thank you, Sonal. Thank you for the introduction. Hello, everyone. Good afternoon. My name is Lakshman Gad. On the screen, you see two gentlemen, Mr. Nitin Chaudhary and Mr. Shashidhar Kumar, who co-founded Sri Rapid Technologies in 2007 and established it as a provider of digital manufacturing solution. This is our pan-India presence with our head office in Mumbai and branch office in Delhi and Bangalore. Backed with 17 plus years of experience, we are a team of 95 plus and we have installed more than 850 machines across India. We offer wide range of 3D printing technologies, starting from the filament based FFF 3D printer, resin based SLA and DLP 3D printer, powder based SLS 3D printer, metal 3D printing, multi-jet printing and even ceramic 3D printer. This shows a complete digital manufacturing workflow what we provide, starting from the softwares which are essential for 3D printing, industrial grade 3D printers from different OEMs, 3D scanners for inspection and reverse engineering, to the post-processing solutions, which also includes dyeing or coloring of SLS 3D printed part. The system you see here, ATO, will be discussed in detail during today's session by the expert Mr. Marius from 3D Labs. The most important part of Sri Rapid Technologies is our Customer Innovation Center, CIC, which is located in Mumbai, Marol, where customer can come down, understand the different technologies in 3D printing. You and your team are welcome to experience and witness the live working of different 3D printing technologies at our facility in Mumbai. So that was a brief presentation about Sri Rapid Technologies. Now I would request my moderator Sonal to take the session forward. Thank you.
Thank you, Lakshman. So, thank you for setting the stage so well. So, going forward, we will have a technical session. Now, it's my pleasure to introduce you to our keynote speaker, Marius Lesnick, Sales Director at 3D Lab. With over 15 years of experience, Marius is a metal powder specialist and a leading expert in ultrasonic metal automation. He has been instrumental in developing innovative flexible metal powder production technologies that are making global impact. Marius, the virtual stage is yours. We'll share you the access and you can start sharing your screen.
I hope you can see my screen right now. Thank you for a warm introduction. Thank you, Laxman. Thank you, Sonal. Can you tell me if you can see my screen right now?
Yes, your screen is visible.
Thank you very much. During today's session, I would like to introduce to everyone, welcome everyone. I would like to introduce our capabilities. I would like to explain you a little bit more about technology and how we can help our customers to improve their powder production and new alloys development. Let's start from the short information about our company. We are located in Warsaw, very close in Poland, very close to the airport. That's why in every case, our customer needs to visit us to check the technology next to the machine. This is a very convenient way to know more about us. I would like to start the main topic for this webinar from the explanation about the key challenges in metal atomization technology, which leads us to the question why we developed a new atomization technology. For this meeting, it's really important to tell you more about the context behind our ultrasonic atomization technology. You should know that 3D Lab was founded in 2007 and we started as a service bureau. 1 year later, we signed a company agreement with 3D Systems. We are a reseller of 3D Systems here in Poland, like ShreeRapid in India. Few years later, in 2016, we signed a very similar agreement with a coherent partner. Nowadays, they are calling 21 Lab, and they are a manufacturer of small 3D metal printer. And this time was crucial for us because between 2008 and 2016, we sold some number of metal printers, and those customers started asking us questions about new alloys, about small amount of powders for testing and research purposes. That's why we realized that there is a niche for small and compact atomizer. And that's why in 2017, we started investigation about our ultrasonic atomization technology, which was born here in 3D Lab. The effect of that was the acquisition of investment partner in 2018, and then we launched the first device in 2019. Since then, we already sold more than 80 machines worldwide. As you can see, our technology is closely related with the bottlenecks in metal additive manufacturing industry and gas atomization technology, mainly because of the limited list of materials you can create with the classic gas atomizer, very high price of those solutions, high operating costs, of course, large space requirements, and very slow material change process. Based on our customer experience, if you would like to ask a big company equipped with classic gas atomizer, you cannot ask them for small amount of powder. In many cases, the minimum amount of powder you can order is 100 kg or 150 kg. And the material change process is very slow, as I mentioned. That's why it's not profitable for them to work with you with very small amount of powder, like few kg. During creation our technology, we were guided by the idea to avoid big construction, to avoid open fire. And we believe we achieved three major goals by creating very small and compact machine to speed up new materials development, but for most, we can propose it with very, very affordable price. All our efforts resulted with the creation of AtoLab Plus ultrasonic atomizer. Nowadays, we are proposing already a third generation of this device, which can work with both TIG or plasma heat source, which can be equipped with 4 ultrasonic modules. Later, I will explain you what we can do with 4 ultrasonic frequency modules. The machine itself is really compact, it's very user-friendly, and it can work with both reactive and non-reactive materials. We already tested more than 350 different materials, and we can work with the materials with the melting point up to 3400 degrees. For other group of our customers, we also developed a special version of this device. The technology is the same, but the machine is called AtoNoble, and it's dedicated for precious materials like platinum, gold, silver. Many of our customers from different industries like electronic goods, like jewelry industry, or even the medical industry, asking us for precious materials. And with this machine and with special filtration system, which can allows our customer to recover almost all powder from the filtration system, this is very beneficial version to work with the precious materials, like I mentioned. Gold. We already tested few types of gold, also platinum and other precious materials. The effect of that is very good quality metal powder, like this report I can show you right now from 22 karat gold atomization process with our induction melting system and 52 kilohertz setup. The general rule, as I will mention later, is the higher the frequency, the smaller the particle size distribution. So depends our customer needs, we can change the particle size distribution with keeping very good flowability and great sphericity. Okay. Right now, I would like to tell you more about the technology itself. For both machines, like AtoLab Plus or AtoNoble, is the same. As you can see on this video, the machine itself is very compact. My favorite comparison is to classic refrigerator. Maybe it's a little bit bigger. It's equipped with a very nice control panel. The position of the operator is very up straight, so it's very convenient to work with the machine. And as I mentioned, it's dedicated for both reactive and non-reactive materials. In the middle of the video, you can see a process chamber, the part with the green light. In the process chamber, we can work with multiple different materials, and we can work with multiple different feeding systems. On this video, you can see a wire feeding system. Melting tip, this is the place where atomization is happen. TIG is our heat source to melt the input material on the top of the atomization platform. And this is the heart of our device. Because the atomization platform is connected with the ultrasonic generator, it means at certain amplitude with certain frequency, we can eject a perfectly spherical metal powder from the molten metal. And thanks to the argon gas, which is our cooling gas, transportation gas, we can move all particles through the chamber, through the cyclone, directly to the collecting container. And all dust or fumes below 10 microns are going to the long life filtering system. And it's very important to underline this filtration system because it's pretty unique. This filtration system was specially designed for this machine, and this is a long life filtering system. To be honest, none of our customers since 2019 asked us for the new filtration system. It means whenever you are working with reactive or non-reactive material, and even you are swapping between those materials quite often, you don't need to change the filtration system. One more time, this is not a standard HEPA filter. we can extend a lifetime of the filtration system by additional semi-automatic procedures, which can be released from the control panel by the operator. Right now, I would like to focus about the efficiency of the atomization process. Maybe you already know that our machine, the basic module, I can call it a basic module as well, it's equipped with multiple different feedstock. For now, you can see the process of atomization from the wire. On the right-hand side, you can also see very simplified scheme how the technology works. More or less, this is the same I was talking about during the video. We need to put the input material to the system. Then with the plasma or TIG, we can melt the input material on the top of the atomization platform, and we can eject perfectly spherical metal powder from this molten metal. To work with the wire, this is something very convenient for the operator. You can imagine a big spool of the wire you can put to the system, and the process can be almost automatic. We can also equip our customer with the remote control tablet. Then you can go to the separate room and you can check the process. You can stop the process. You can control all the most important settings remotely. As a proof, I would like to show you a very short video from the atomization of nitinol for one of our customers. This customer shared with us the big spool of the wire from nitinol. We've put this nitinol to the system. We fixed the feeding rate. We set up the automatic torch movement. And as you can see right now, the process is fully automatic. At the same time, the operator can go elsewhere and he can check from time to time the atomization process. As I mentioned, you can do this with the wire because you can put a long spool of the wire to the system. But our machine and the basic module, as I mentioned, it's not only a wire feeding system. We can equip our customer with multiple different rod feeding system, like single rod feeding system, which is very great option for R&D department. Whenever you need to work with even small amount of powder or even bend rod, you can use the single rod feeding system or custom feeding system, because some customer in some cases asking us for irregular shape input material, they would like to work with TIG or plasma, for example, with the refractory alloys. So we can prepare a custom feeding system for those customers. But to increase the efficiency of the process, for example, from rods, we also developed a revolver rod feeding system or multi-rod feeding system, which allows you to work with multiple rods or even one very long rod, more than 1 meter with the length. Right now, I would like to tell you more about the possibilities to change the particle size distribution, which is very important because many of our customers, depends on the industry, can use or can be equipped with, for example, different 3D metal printers like LPBF, EBM technology, or DED technology. For those customers, we improved our system. I will show you this here. I hope you can see my screen right now. On this graph, you can see 4 different frequencies. The basic machine is equipped with 35 kilohertz ultrasonic module. It allows them to work with the biggest amount of the powder between 40 to 60 microns, which is more or less a gold standard, for example, LPBF technology. But for those customers who are asking us for smaller particles, we can switch to smaller particle size distribution by implementing a higher frequency system, like for example, 52 kilohertz. Another group of our customer asking us for even smaller particles. That's why a few months ago during the TCT Rapid show in Detroit, we presented the ultra high frequency system, 72 kilohertz system, which allows you to switch to even smaller particles with the biggest amount of powder between 20 to 25 microns. We can't forget about this group of customer who is using, for example, DED technology or EBM technology. For those customers, we developed low frequency system with 20 kilohertz module. As you can see here, depends on your needs, depends on your purposes, you can switch from multiple different frequency. And right now, I would like to mention about another game changer in our industry. I mean, induction melting system. From the historical point of view, many of our customers asking us for recovery of scraps, failure printouts, CNC scraps after CNC technology processes. That's why more than 2 years ago, we developed induction melting system. Nowadays, we have a second generation of this machine, which allows you to work with completely irregular shape input material. So whenever you need to recycle some scraps after 3D printing metal process, maybe supports or CNC scraps, or even short or longer bars, you can use the induction melting system, which is much more gentle for the material in comparison to the plasma source, for example. So whenever you need to work with lower melting points elements like tin, lead, magnesium, the induction melting system seems to be the best choice for you. It can work with the melting points material more than 1500 degree, and it can turn your scraps or even another powder to a perfectly spherical powder with very narrow particle size distribution. I think this graph can be also helpful for you because it's showing that we can work with both crucible and rod feeding system using our induction melting system. I will explain you how it works. Obviously, we can work with different sizes of the crucible and different types of the crucible, depends on the material. But sometimes, if you would like to avoid a cross-contamination from the crucible itself, you can feed your induction coil directly with your rod. That's how we achieved, for example, great results with magnesium. I can tell you a great example. One of our customers have a problem with atomization of magnesium. They are a user of our ATOLab basic module since 2023. But once they asked us to switch to magnesium, they found out that the evaporation for the magnesium was a little bit too high. That's why we proposed them to work with the induction melting system. So we atomized for them highly medical grade magnesium like ZX00 or WE43 magnesium, and we achieved great results with this powder. The sphericity was great, the flowability much better comparing to the classic gas atomizers, but the most important fact, especially with the magnesium, which is very reactive material, we have achieved very safe process with very narrow particle size distribution, and we kept the title of the material in terms of the chemical composition. Right now, I would like to show you another example of atomization with our induction melting system. On this example, you can see 18 karat gold, but please imagine different cases, different scenarios, because in every case, the atomization process with the induction melting system will be the same. On the control panel, we can set the target temperature. We can see the process of the melting point thanks to the mounted camera. We can also check the temperature thanks to the mounted thermocouple inside of the crucible. So we can control all the most important parameters. When the material is fully liquid, we can release the material from the crucible onto atomization platform, and then we can achieve the efficiency of the process between 2 to 4 times better comparing to the basic module. And of course, after the atomization process, we can collect the powder in our collecting container. With this solution, with the AtoLab Plus and induction melting system, we can achieve a full loop. I mean, we can recycle the material. We can recycle the scraps or CNC chips. We can atomize, turn into a perfectly spherical metal powder, then sieve, because it seems to be obvious that we need to sieve the material after the atomization process. Then, for example, we can go with this powder to 3D metal printer with different technology, depends on the PSD you would like to work with, or for example, for cold spraying technology, and the leftover we can turn into a powder again. Additional machine which can help us to improve the research or the efficiency of the process is our AtoCast. This is a self-sufficient induction vacuum casting machine and furnace which can allows you to cast your rods. But the biggest difference between the induction melting system itself is the fact that we do not have any atomization process here. This is only a vacuum casting furnace. But in that case, we can achieve a melting point for the materials up to 3000 degrees. That's why we can work with multiple different scenarios depend the customer needs. Please imagine the situation that you would like to work with scraps. My first thought can be proposing the induction melting system. But for example, you can tell me that you would like to work with the materials with the melting point more than the possibility of our induction melting system. In that case, we can use our casting vacuum furnace. We can cast rods, which can be perfectly homogeneous. We can also pre-alloy the material, and with those casted rods, we can go to our main module. Thanks to the AtoCast, we can achieve this loop. So whenever you need to work with scraps, different shape of the input material, irregular shape input material, you can turn this material into a rod form, then you can atomize in our basic module, and the rest of the process is the same. You need to sieve the powder, and you can go with the powder to your technology like 3D printing technology or cold spraying technology. Right now, I would like to mention more about the quality of the metal powders. After many tests, we can be sure that oxygen level, the particle size distribution, the chemical composition can fulfill even our demand customer needs. First of all, you need to know that we are testing a lot of materials. We already tested more than 350 different materials for induction melting system together with our main module. And you need to know the biggest difference between the ultrasonic atomized powder and classic gas atomized powder. And the biggest difference you can see on those pictures. On the left-hand side, you can see the atomized powder with the classic gas atomizer, and on the right-hand side, you can see our powder from the ultrasonic technology. How it works? The biggest difference is in the production. Whenever we are speaking about the gas atomization technology, we need to be aware that the powder is created by high-pressured gas nozzles, which can turn the liquid material into a powder form. That's why in many cases you can observe a satellites. It means, and it's resulted with the much worse flowability and the powder quality. In our case, we are not using any force. We are using only a vibration, the ultrasonic vibration. We are putting through the platform, and that's why we can eject a perfectly spherical metal powder from the molten metal. Here you can also check another examples like copper. We can easily atomize with our induction melting system, and the efficiency is very nice for the copper especially. the highness 282 material, or tantalum. Another example is to show you the differences between three different particle size distribution. The blue one is 52 kilohertz, the gray one in the middle, it's 35 kilohertz setup, and the orange one, the 20 kilohertz setup. It's worth to mention that whenever you are atomizing the material, it seems to be obvious that you need to sieve the material after the atomization process. To maintain the quality of our powder, we developed our ultrasonic sieving station, which is fully compatible with our ATO container. It means, for example, you can close the valve in your atomizer and put your powder in a safety way under argon atmosphere to your sieving station, and you can sieve your powder also under argon atmosphere. So whenever you need to work with highly reactive material which can oxidize a lot, like magnesium or titanium, you can also work with the ultrasonic sieving station, which can improve the sieving process by avoiding a clogging. Also, ATO clean is very important due to the context behind this webinar, because as you know, a few minutes ago, I've mentioned about the slow material change process in terms of the classic gas atomizers. With our machine and ATO clean, you can swap between one material to another, avoiding cross-contamination within 2 hours. This is fully automatic process. The only thing the operator should do is unmounting the few parts from the ATO. It can take up to 15 minutes maximum, and then the automatic washer will do the rest. After the cleaning, you need to mount the parts again, and you can start completely new atomization process without cross-contamination. Also, something new in our portfolio, it's ATO wipe. Sometimes we can see that our customers are sending us very dirty material, both wire or rods, or even scraps. We found out that the grease film on the top of the layer of the input material can disturb the atomization process. That's why we developed this automatic cleaning unit, which can be helpful to increase the efficiency of the atomization process. Also, I would like to mention about the situation when our customer can purchase for us or from our partners like ShreeRapid a combo solution. Whenever they need to work not only with new materials, but maybe they need to print some parts or maybe test new powder with their 3D metal printer, we can deliver, or partner can deliver, a combo solution. It means not only the atomizer, but also a 3D metal printer, depends on your needs. This is also a good example of big machine we delivered to our customer from the gas and oil industry, and they are working with big amount of powders, especially with 316L steel and Inconel, which they are creating on our ATO lab solution. Many of our customers worldwide trust us. Many of those customers buying from us second machine. In some time, they are also asking us for multiple updates, upgrades. You need to know that we can access to all our machine remotely. Obviously, we cannot do this without customer permission, but sometimes whenever they need to work with new material, maybe they are from research centers, from universities, they can ask us to connect with their machine, and we can help them. We can guide them with new parameters and with the proper settings for their materials. It's worth to mention as well that we do not only developing the technology, we are also working to secure our technology. That's why we are receiving more and more patents to secure the technology. This is an example of the patents from Korea, Japan, and United States. Especially the patent for United States is important for us. To sum up my presentation, I would like to show you a short video which can explain you what is the size of the machine and what we can do with multiple different modules from our portfolio.
Introducing ATO Lab Plus, engineered to make any powder from any metal right when you need it. Simply mount a standard metal wire spool from any alloy, reactive or non-reactive. Device has small footprint and don't need complex infrastructure. Just plug in and start atomizing. Built-in long-lasting filters ensure powder and system safety and efficiency. Device have modular construction. Choose ultrasonic frequency system module to control produced powder size for your application. Use automatic feeding and torch movement features to reach maximum powder production efficiency. ATO delivers highly spherical powder with excellent quality and flowability, ideal for additive manufacturing and beyond. While ATO making metal powder, your hands are free for other tasks. ATO remote control allows to control one or multiple atomizers. Get a live view of atomization and control process remotely with dedicated tablet. All modules are easy to swap. Minimal downtime, maximum flexibility. Change feedstock by swapping feeding module and make metal powder from rods with single rod feeding system. Atomize metal rods quickly and efficiently with full control over feeding speed and rotation. Control atomization and parameters in real time with main touchscreen panel with dedicated knobs and easy to use software. ATO ultrasonic metal atomization technology ensures efficient, stable, and flexible powder production. Make high-quality spherical metal powder from your alloys with precision. For bigger production cycles, the multi-rod feeding system is the ideal choice. This module allows you to queue multiple rods in a single atomization run without unsealing the chamber. Simply load your rods and start producing high-quality metal powder. The feeder offers exceptional adaptability, supporting various rod sizes with ease. When extended production is needed, you can equip the system with a dedicated extension tube, enabling atomization of rods up to 1.2 meters in total length. This minimizes downtime, reduces reloads, and ensures efficient, continuous powder production. Expand your range with the induction melting system, perfect for atomizing metals with lower melting points. When combined with rod-based feeding, it enables fully contactless powder production, ensuring maximum chemical purity. The IMS uses induction heating to warm both the feedstock and the atomization platform, providing a stable, efficient process. Atomization is carried out on our patented ultrasonic tip, which ensures consistent droplet formation and excellent powder sphericity. Irregularly shaped feedstock or 3D printing leftovers? IMS handles them with ease using crucible-based feeding. Inside the crucible, materials can be fully melted and alloyed through induction electromagnetic homogenization. Once ready, the pressure-controlled pouring system releases the melt precisely onto the atomization platform, minimizing contamination risk and ensuring consistent powder production. With this method, you can atomize up to 350 cubic centimeters of your alloy in one batch. Achieve unmatched powder quality and chemical purity, ideal for advanced applications. When atomization is done, turn off atomizer with one click and collect produced powder. Our universal sealed powder container keep material in inert gas atmosphere to protect from oxidation. Use the ATO sieve to separate powder by size and make ready to use. It's ultrasonic sieving station with sealed chamber in inert gas atmosphere. Ultrasonic vibration prevents clogging and boosts sieving performance. Efficient, clean, and consistent. Sieving made easy. ATO metal powders is ideal for use in additive manufacturing and advanced applications with excellent flowability and narrow particle size distribution. Close the loop and recycle metal scraps from 3D printing with ATO Cast. It's a professional induction vacuum casting furnace with compact all-in-one design. Fill crucible with your metal or 3D printing scrap and mount securely in induction coil. By preheating casting mold, you're reducing risk of defects during casting. Take and secure mold with metal clamp and position directly under crucible drop spot. ATO cast chamber works in positive or negative pressure version and with inert gas shield to reach highest material quality and purity. When all is sealed, start induction melting on main touchscreen panel and watch how your feedstock becomes liquid. Material fully homogenizes with induction electromagnetic field. Once the melt reaches its ideal state, pour it into the casting mold with a firm motion. Casting is now complete. The rods can be safely extracted and used as fresh feedstock for powder production. The ATO suite is more than a set of machines. It's a gateway to material innovation. It empowers researchers, engineers, and manufacturers to explore new alloys, reclaim materials, and shape the future of additive manufacturing. Make metal powder yourself and redefine what's possible. Visit ato.im.
Thank you very much for this part of the webinar. I hope that was the informative time for you. And Sonal, I believe we can switch to the next part of the webinar.
Thank you, Marius. Thank you for that deep and insightful session. So let's move on to our question and answer segment. We have received some questions and I'll read them out to Marius to address one by one. If you haven't submitted your questions, please submit them via Q&A section or the chat box. We will read it out. Okay. So the first question is from Prakash. Is it possible to study the semiconductor material doped metal powders? Is it possible to create a defect inside the metal powder?
Sonal, is there any place I can see the question? Ah, okay.
Marius, can you see the question?
Yes, I can see the question. Give me a second. I would like to understand the question better. If our customer, Mr. Prakash, asking us to show him some examples of the reports we already made or something else. To be honest, I'm not sure if it's possible. We can double check and answer your question after checking with our R&D
Yeah,
department.
sure.
After our
We'll
R&D
get it
department.
checked first, what it is possible. And yeah, sure, we'll let you know, Prakash. We'll connect to you personally and let you know. So let's move on to the next question. So we are looking for plasma atomizer for producing titanium with a 20-ton per annum outlook. Can ATO machine provide similar volume with better yield?
Okay, I'm reading the question. Give me a second. Yes, thank you. Thank you for this question. It's quite interesting. The material you have mentioned, it's one of the easiest material we can produce, but the efficiency it's strictly related from the input material you would like to work with. For example, the better and the most advanced efficiency you can achieve with the wire feeding system. As I mentioned during the presentation, the efficiency in that case will be the best. To achieve 20 ton per year, it's also possible. We can calculate it for you, okay? Maybe we can adjust also the technology for your purposes. But sometimes, whenever it comes to such calculation, we can find out that the customer should purchase not only one machine, but for example, one, two, or three machine. Anyway, it is much more cheaper than classic gas atomizer.
Okay, so the next question is by Ronak Singh. Can you pour the liquid metal directly on sonicating surface to atomize in larger quantity?
Give me a second, I will read the question. Yes, of course, we can pure the liquid material directly on the platform. And this is more or less, this is the description of our induction melting system, because whenever the material is fully liquid inside of the crucible, we can release the material from the crucible in a liquid form, as you mentioned, onto atomization platform. And this efficiency is around 2 to 4 times better comparing to the main module when you can work with rod or the wires. Long story short, it's possible to achieve this goal.
Okay. So the next question is by Ali Mohsin. What are the benefits of plasma compared to TIG? What is maximum throughput of machine, especially the induction?
Okay, thank you. The biggest difference between plasma heat source and TIG source, which can be implemented in the main module, is the density of the energy you can put into one spot. Okay, so between TIG and plasma, it's a big difference. That's why, in terms of the reactive, maybe not reactive material, but non-refractory alloys especially, you can achieve better results. Whenever you need to work with higher melting points material, for example, close to 3000 degree or even more, the plasma system will allow you to work with those materials in more efficient way. You also ask what is the maximum true output of the machine, especially the induction. I believe you are thinking about the induction melting system, which I showed you during the presentation. The maximum true output depends from the crucible size and the density of the material. We are giving the information of the true output not by the mass, but by the volume, like I mentioned, because of the density differences. For example, to answer your question, for example, we can atomize more than 2.5 kg of copper per 1 hour. We can atomize with the induction melting system. We can atomize more than 2 kg of gold per 1 hour. But for example, for aluminium, it will be around 1 kg per 1 hour.
Okay. So the next question is by Dr. Bhavesh Mewad. How do you control the particle size?
Okay, very good question. I will try to answer it one more time. The particle size distribution is controlled by the different frequency modules. The basic machine is equipped with the 35 kilohertz system, but whenever you need to switch particle size distribution to smaller or bigger particles, you can adjust, you can implement additional option to your system, which allows you to switch this particle size distribution. It's a very easy process. It can take only 10 to 15 minutes by the operator. And with those additional modules, you can change the particle size distribution. It means mainly the frequency can affect the particle size distribution. The general rule is as follows: the higher the frequency, the smaller the particles. The lower the frequency, the bigger the particles.
Okay. The next question is Ronak Singh Parmar. What can be the maximum production capacity per hour?
Also, very good question. Thank you. But it's related to the different feeders. At the same time, yeah, I can also ask another question. If we are talking about the wire feeding system or rod feeding system, later I can also ask if we are talking about the single rod feeding system or multi-rod feeding system. Uh, for different modules, the maximum production capacity per hour can be different. For example, the higher maximum production rate we can achieve with the induction melting system, as I mentioned, then with the wire feeding system, because as I mentioned, the wire is very convenient for the operator and you can put big spool to the system. And with the wire, you can achieve up to 0.3 liter for hour. Okay. As I mentioned, we are giving the information with the volume instead of the mass because of the density differences. One more example. For the wire, for example, with stainless steel, it will be 1 kg from the wire. It will be 0.3 liter, this 1 kg. The same amount of powder, for example, titanium, still zero point 0.3 liter, it will be around 600 gram per 1 hour. So everything is related to the density.
Okay, thank you, Marius. So next question is again by Ali. Can 72 kilohertz work with all materials and induction? Are there any contaminations from the atomization process in induction?
Thank you for this question. We have four different configuration in terms of the frequency. I will enumerate all of them: 35, 52, 72, and 20 kilohertz. All of them are implemented with our AtoLab Plus. Uh, in terms of the induction melting system, we already implemented 35, 52, and we are under implementation of 72 and 20 kilohertz. So within few months, all frequency systems will be already implemented with our induction melting system. What about the contamination? In terms of the induction melting system atomization process, we are not observing any contamination because, especially with the induction melting system, we are working with the low melting elements and, for example, precious materials. Those customers are especially afraid about contamination. You can imagine the jewelry market or medical market, and they are checking almost all the time the chemical composition. With the induction melting system, we can achieve great chemical composition comparing to the input material. So we can keep the title of the material by the fact that the induction melting system is much more gentle for the material comparing to, for example, plasma system.
Okay, thank you, Marius, again. So this is the last question I think we have. What is the time taken for material changeover and time to reload the new material?
Okay. This question is related to the cleaning procedure, and it's a very important question because, as you noticed during the beginning of my presentation, I told you about the classic gas atomizers when it's not profitable for those companies to change the material often. Those solutions are very big and it's hard to clean. It's minimum 3 days to even 1 week to clean the gas atomizer before you would like to switch to another material. In our case, answering your question, Mr. Rahul, we need only 2 hours to clean the material, to clean the system before you start completely new process without cross-contamination. To do that, you need to unmount from our ATO process chamber, cyclone, and collecting container. This procedure can last only 10 to 15 minutes, and with the ATO Clean, our ultrasonic cleaner dedicated for this process, you can achieve completely cleaned system without cross-contamination within 2 hours. Then you can start a new process.
Okay, thank you, Marius. So, as we wrap up, I would like to extend sincere thanks to Marius Lesnick for sharing his expertise and to 3D Lab for partnering with
Thank
us
you
to
very much.
make this session possible. A big thank you to Sri Rapid Technologies team for organizing this event, and most importantly to you, our audience, for your time and active participation. We would like to invite you to visit our Customer Innovation Center in Mumbai, where you can experience 3D printing technologies live and see benchmark parts in person. So this is the visuals you see on your screen is from our Customer Innovation Center, and also you can also see the details for where you can write us down any queries you have regarding 3D printing or any end use parts you want, or also booking an appointment to this center. You can for email us at marketing at shreerapidtechnologies or call us at the given number. Also, this webinar recording will be forwarded to you in a day's time, and you will receive it through email. Connect us back for any questions, and following at the end of this webinar you'll have survey questions. Please do answer the same. Thank you once again for joining us, and we look forward to see you in next webinars. We will be holding more webinars in future, so please do attend those same as well. Take care. Have a great day. Thank you,
Thank you
everyone.
very much. Thank you.